Hello, my name is Julia Minaeva. Let me present my work Tensor models for data extraction and use of hidden knowledge in the environment of uncertainty modeled by fuzzy sets of type 1 and type 2. Fuzzy set theory is now a particularly universal apparatus that is used in almost all cases where there may be uncertainty. The circumstances that, in our opinion, contributed to this phenomena are as follows. The subset of ordered pairs, which is the main element of the mathematical apparatus of fuzzy set theory, assumes its flexible modification. Depending on the level of uncertainty, type 1 fuzzy set can be extended to type 2 fuzzy set and be a subset of ordered sequences. The presence of a component membership function, which requires virtually no mathematical constraints and almost entirely depends on the opinion of the experts, allows you to adapt the mathematical apparatus to almost any type of real uncertainty problems. The object of research is matrices. The subject of research models provides hidden knowledge that tends to make the solution of fuzzy equation based on the concept of the nearest which are based on the use of tensor products of fs components in the Machiavellian uncertainty. To show the equivalence of tensor models fuzzy set 1 and fuzzy set 2 type with SOP obtained by singular decomposition of the tensor model fuzzy set. To identify the possibility of 3D tensor representation of uncertainty and identify areas of rational application of 3D models. To identify hidden knowledge that can be used in tensor modeling of uncertainty. To develop methods of solving equation at the level of matrix equation by using Kronecker algebra. Problem statement. Recently, a number of uncertainty problems have emerged, the solution of which by fuzzy set theory methods, in particular by fuzzy mathematic methods, is either extremely difficult or the result is not constructive. This is especially true for data processing, which belongs to the category of big data, where ultra-high dimensionality is combined with a large amount of data and thus necessitates working with 3D data problems at one fuzzy set in the form of 2D simulation and of ordered pairs of calculate. On and 3 models from tensor models of type 1 and type 2 fuzzy sets are not only significantly strengthen the arsenal of methods of fuzzy mathematics, but also can be an additional channel for comparing the quality of the obtained solutions. The concept of tensorization refers to procedures for generating structured tensors of high order from low-order data formats, or representing very large system parameters in low-order tensor formats. For any given source data format, the tensor procedure can affect the choice and the efficiency for tensor decompositions in the given steps. Material and method. Fuzzy set theory had formed the main object of the theory, subset of ordered pairs, as a procedure for heuristic blurring of a universal set and its representation as a set of levels. Fuzzy logic of development of the accepted concept naturally lead to type 2 fuzzy set formed as a procedure of blurring crisp values of membership function type 1 fuzzy set. The ability to represent subset of ordered pairs as 2D and 3D object requires an assessment of their proximity. Fuzzy set is represented as a tensor model. The main advantage of the nearest fuzzy set concept is that it's possible to use hidden knowledge that is contained in the set of initial data and accumulated in the fuzzy set. There is an additional channel to obtain information for the formation of membership function. There is a possibility of processing 3D data under conditions of uncertainty, and the possibility of simplified analysis using type 2 fuzzy set. Additional possibilities of expanding the classes of solvable problems under conditions of uncertainty, in particular, the solution of fuzzy equation and system of fuzzy equations of type 2 fuzzy set and multi-fuzzy equations by using the methods of concave algebra. The hidden knowledge that can be extracted from the tensor models of fuzzy sets includes the following primary matrix and tensor invariants. Examples are given on the next slides. Solutions of fuzzy equations where are used fuzzy variables based on two main principles: conversion of fuzzy variable into 2D matrix and formation of a matrix equation, which is solution based on the vectorization procedure. General scheme of computer simulation of implementation of main tasks is given below. The example of representation of separate window of a 3D time series in the form of tensor model is given below. You can see representation of time series, its representation of a frontal slices, formation of block diagonal matrix, and we can discuss the results of the main example. Below are fuzzy set with triangle membership function and the nearest crisp set, their F norms, Frobenius norms, and the specified values. On the figure, you can see the initial fuzzy set and system of ordered pairs formed as a result of singular decomposition of the tensor models. As you can see, as the result, this example confirms the main statement. The results obtained by the singular decomposition of the tensor models of the initial fuzzy set adequately represents the initial fuzzy set. As you can see on the tables and values, differentified values, and Frobenius norm values, the statement is correct, and we can use a subset of ordered pairs obtained by singular decomposition to solve such tasks. Conclusion. The theory of fuzzy set is now particularly universal apparatus, which is used in almost all cases where there may be uncertainty. However, the match of new problem requires continuous expansion of the standard theory of fuzzy sets. One of the areas of possible research is tensor modeling of uncertainty, which is based on the nature of fuzzy sets, a subset of ordered pairs. The representation of type 1fs or type 2 fuzzy sets as a tensor product of components is offered. The result is a 2D tensor or 3D tensor in case of large dimension. This approach allows to use of the possibilities of tensor matrix analysis for solving problems under uncertainty, along with fuzzy set apparatus realizing the extraction of new knowledge, which significantly expands the range of problem under uncertainty. Based on the concept of extracting hidden knowledge, a method of automatically creating fuzzy sets by structuring the initial data set with subsequent tensor decomposition is proposed. The obtained SOP is endowed with all the properties of membership function. If it's impossible to implement the procedure of structuring initial dataset, it's proposed on the basis of calculating the values of creating the universal set vector and delivering the later by using special matrices, matrix decomposition of which will create subset of ordered pair analog of fuzzy set. It is shown that tensor models of standard type 1 fuzzy sets allow representing this object simultaneously as a 2D tensor, 3D tensor, type 2 fuzzy set with sparse Bethel set, and multi-fuzzy set. In addition, the standard type 2 fuzzy set can be represented as type 1 fuzzy set, preserving the properties of the original object. Spanner's norm, defuzzified value. This conclusion allows us solve fuzzy equation in which the coefficient and unknown are fuzzy variables of types 1 and 2 at the level of standard matrix equations, followed by the transformation of the matrix solution into the subset of ordinary pairs.